It's Thursday, the 21st of November, and welcome to the Water Action Platform, a 30-minute broadcast in which we share stories from across the water sector. This week, we've stories from Samoa, India, Australia, and Europe. Hope you enjoy the ride. Thanks, as always, must be given to our sponsors, a glorious mix of utilities, consultancies, contractors, research organisations, trade associations and investors. It's undeniably a broad church of supporters that reflects the ethos and values of the Water Action Platform, namely that these broadcasts are free and available to everyone. Our goal here is simply to share interesting and inspiring stories. And talking of which, our first story is an update on a recent trial reservoir supported trial in Samoa. As you might recall, the trial reservoir is a pot of money that ISLE distributes to help technology companies undertake trials. The caveat is that if the trial is successful, i.e. it meets its preset KPIs, then the end user, usually a utility, is obliged to adopt the technology. Now I say it's a caveat, but some might actually say that that is the genius behind the whole trial reservoir concept. The aim of the trial reservoir is to facilitate and encourage the adoption of new technology, in particular technology that will help address the burgeoning climate crisis. So here to share more about the trial in Samoa with the technology company Bynry is my colleague Rashmina William to share some more.
I'm excited to introduce our most recent reservoir trial between Bynry, a tech startup located out of Pune, India, and Samoa Water Authority, the primary water utility provider for the Pacific Island nation of Samoa. Bynry Smart 360 is a software-as-a-service platform specifically designed for medium to small-sized utilities looking to improve their billing and meter reading accuracy, customer service, asset and work management, and overall system efficiency. By increasing automation and reducing manual data entry, Smart 360 helps to reduce user error, saving utilities money, and also minimizing paper waste and reducing Scope 3 carbon emissions. Samoa Water Authority manages a network of 29,000 meters that monitor service for a population of 250,000 people distributed across the Samoan archipelago. However, their current 15-year-old system can no longer keep up with the demands of this rapidly evolving and growing utility. The utility struggles with a lack of effective digital infrastructure, which not only leads to system inefficiencies and unaccounted for water loss, but also impacts their customers' user experience. Samoa Water Authority is leveraging this trial as an opportunity to pivot towards a more agile, cloud-based asset management framework, and in doing so make their system more resilient and future-proof. The goal of this pilot is to allow the Water Authority to accelerate their digital transformation while lowering their cost of ownership, boosting their return on investment, and streamlining operations. Over the next 5 months, Bynry and the Samoa Water Authority will pilot the Smart 360 software on a smaller network of 5,000 meters and a subset of the Samoa Water Authority customer base. After a final month of end-user trialing, the Water Authority aims to move towards a phased rollout of Smart 360 across the rest of the system at a rate of roughly 5,000 meters per quarter. I was privileged to speak to Nilesh at Bynry and John at Samoa Water Authority to learn more about this trial and what they hope to see as its immediate and long-term outcomes.
Bynry INC is a US-based software-as-a-service product company specifically designing the product for utility industry. Our flagship product Smart 360 is a cloud-based AI-powered smart utility platform for small and medium-sized water, electric, and gas utilities. We are transforming the way these utilities are managing their operations, increasing their revenue, and the way they are managing the experience for their consumers. We aim to support around 1,000 small and mid-sized utilities by 2028, transforming the way they are managing the sustainability at their end.
Smart 360 caught my eye mainly on them being built on sort of cloud-based tech. It's a platform where you can access the different modules, whether it's in the office or out in the field. So the system that we currently use is something you can only access internally. There hasn't been any ability to access the customer data information from outside of the field. So I guess that was one of the selling points that Bynry had from the legacy system that we currently use.
And tell me a little bit more about this pilot, this trial that you're doing. What are you most excited about seeing in the next 5 months?
For me, really, the excitement was when I found out it was cloud-based and you can access it from your mobile. I guess it's now down to the users. I'm most excited about the way it will change the way they do their work. We've applied different ways and tools, software to try to mimic what I believe Bynry would provide with the legacy system we have in place. So it's that uptake by the users that I'm excited about, and the changes in the way we do things, the processes internally within the organization.
In my 24 years of experience in technology and 8 years of working with utilities, I came across many utilities, and I'm quite surprised that they are still using the legacy technology, and it is not helping them. Here at Samoa Water Authority also, they have implemented their technology almost 20 years before. And with changes in technology and changes in the field, the technology is not able to support their current operations and the business needs. Hence, we started the trial of Smart 360. As part of trial, we are going to transform how they are managing their 28,000 consumers. We will also, transform their consumer management, consumer experience, how they are managing their meter and meter readings, how they're doing billing, how they are managing their recoveries, as well as the service and service orders and asset management.
From the authority's perspective, I think over the last 10 years, the authority has taken up several different application software in order to deal with certain issues. And despite having the system that we have in place, I found that we're slowly developing what we would call data silos. So one of the difficulties is having to actually provide sort of a deep analysis of the information that we have on hand. So, in terms of the authority, we would like to see how we can make a better informed decisions based on the data that we currently do have, and how we can bring the data that we do have into the Bynry platform. So yeah, it's a challenge on the Bynry team as well.
This trial is a key milestone for Bynry. First of all, mainly because once the trial is completed and we successfully launch Smart 360, it's going to directly impact the life of 50,000 Samoan Islanders here, who will have a better access to quality waters and overall serviceability around the water they get. Secondly, it will also open the doors for Bynry for remaining 20-25 small and mid-sized water utilities in the region who has a similar challenges similar to Samoa.
Well, we're really excited to see how this project evolves and develops over the coming months. Any final closing thoughts or comments?
I think that's something I'll leave once the pilot has concluded.
Mm-hmm.
Because right now, we're still on that buzz of actually implementing. It's been about a year of discussions. So now that the team will be in a couple of weeks, we've got about 5 months to trial it out. So I'll have my final thoughts then.
And we're
too early to tell.
Absolutely. And we're looking forward to having you back here on the Water Action platform to talk to you after the trial's concluded, and we can see some of the fruits of your labor. This has been a very long time coming, so we're very excited to see the product of this trial.
So lastly, the trial wouldn't have been possible without the support of iUtilities. I would like to give my special thanks to Rashmina and Joe for their support in last 6 months. At the same time, I would like to appreciate John and Dominic from Samoa Water Authority for trusting us and our platform. We think this is the right moment for us to create the lasting impact by collaborating with high utilities as well as the Samoa Water Authority and co-create the value for all island people.
Thank you to John and Nilesh for those fascinating perspectives. Now, as of this recording, the SWA Bynry trial is well underway, with the Bynry team having implemented their first site visit to the islands. Now, as you've heard, this trial marks a significant milestone for both SWA and Bynry, a turning point in the authorities' digitization journey as they move towards a more mobile-friendly, cloud-based system, and a stepping stone for Bynry, opening up the market to other potential Pacific Island customers. We're looking forward to continuing to keep you updated on their progress in the coming months.
Thank you, Rashmina. If you want to know more about the Bynry trial, or indeed about the Trial Reservoir Initiative and how it could help your organisation, please let me know. We now have a technology showcase on VAPAR from Sydney, Australia, with their pipe inspection technology. Now, they were introduced to me by those very clever people at the investment firm Pure Terra Ventures. They're also a sponsor of the Water Action platform. This is definitely a technology to watch. Earlier this month, I spoke with the co-founder and chief executive, Amanda Siqueira. Amanda has a fascinating background, having worked with a couple of major engineering consultancies and with a couple of utilities, including Sydney Water. She took the learning from this experience and, with a colleague, folded it into the formation of VAPAR in 2018, just before the pandemic. Now, taking a brand new startup business through a pandemic and still coming out with a strong market position and a disruptive, proven technology takes a special sort of person. Amanda, brilliant to be with you. Let's jump straight in. Can you tell me what is different about VAPAR's way of inspecting pipes than what people traditionally do?
Yeah, so basically what people are traditionally doing now is putting in cameras into their pipes. They're tethered little vehicles that go in and they put them in there to try and find blocks and breakages in their pipe network. But all of that video that's cameraed from those instruments are manually reviewed by humans, often up to twice, just to verify whether that blockage or breakage is there. What we do differently is we use deep learning technology directly on that video inspection footage to find the defects. If you can think about it like Face ID for sewer defects.
Excellent. And I know you've got a background in consulting. So when you were at can I say the names of the consultants? No, I probably won't. But these internationally renowned consultancy, you probably saw people doing exactly this work. Was this something you were doing of watching the videos? Is this what drove you to form the company?
Yeah, so actually in my first year of engineering, as an engineering intern, I used to work at Sydney Water, and I was 8 hours a day watching the insides of sewer pipes and writing down whenever I saw anything weird. So that was back in 2009, and it's 2024, peers, and this is still the way that the globe is assessing underground pipes.
Wonderful. I was going to ask, so what led you to start VAPAR? But I think you probably just answered it. Is that right?
That's what certainly was the kind of galvanizing experience for me. But Michelle, my co-founder, and I started in 2018 with that personal experience of kind of like, well, there has to be a better way. But yeah, the product itself has certainly pivoted and adapted over time.
Excellent. All right. So we're still gathering the data using videos, but you're using clever algorithms to analyze those videos to actually detect the defects and removing some of the flaws that humans might have where they drifted off in their attention span or those sorts of things. That the good summary of it?
Yep.
Okay. So now tell me about, give me a time, when VAPAR's, who have you done tested this technology with, and how's it gone?
Yeah, so we started in Australia in 2018, and not long after that, we expanded to the UK. So we're operational in Australia, New Zealand, and over in the UK. We've just started work in the the US as well. So in the North American market, there's a huge market and appetite for what we do in the US. So we've got customers in mainly those regions. Our solution has made a huge impact in the UK. So we work with a number of the water utilities in the UK market. A recent case study that was presented at a conference was actually with Northumbrian Water. And what we do with them is, those that know the UK market well know that there's a lot of reactive inspections that are being done because of, sewer issues and overflows. What we're able to do with them is actually digitize a lot of the inspection footage that people are carrying out anyway and say, hang on a second, let's go back to this and find out the root cause of the defect. And if there's a structural root cause of the defect, raise the work order immediately so that you can actually get it remedied. So with Northumbrian Water, we're able to help facilitate a 8 to 9% reduction in their repeat blockages, which is a huge number for a water company like them. And full credit to them. They implemented the solution correctly, and they continue to use it. So they've actually pioneered the use case.
I just had to pause it there. Has anyone else noticed just how many times Northumbrian Water gets mentioned when people talk about innovation? It's wonderful. Anyway, back to Amanda. I then asked her about the commercial model.
So we charge on a per metre or per kilometre basis, or in the US, per foot or per mile, and it's basically a tiered service. So you tell us how many metres or miles you're doing per annum, and then we come up with a model that works best for you, so that it's all you can eat up to your tier.
Okay, and you're Australia, so you're in Australasia, Australia and New Zealand. You're in Europe and you're in North America. Is that because you've gone English speaking, or is there any reason why you?
Yes, and also the size of the market's the pool, really. So we were pulled into the UK. So United Utilities kind of, I want to say, plucked us out of obscurity in Australia and brought us into the UK market. So they actually incubated us and pioneered the technology in the UK. And then the US as well has been a pull, and of course language has helped. But we're about to release some language packs that can help us scale into non-English.
Wonderful, right? So what's the future? What happens next? Are you now looking for more clients? So tell me two things on the future. One is, so where are you at in terms of client acquisition and clients you can serve? And what can we do here to help spread the word? And secondly, what are you doing with new features on the product?
Yep. So clients-wise, so the regions that I've mentioned, it's specifically ANZ and the UK is where a lot of our footprint sits. We've just started work in the North American market. Super exciting market. Very, very big need for what we're doing. A lot of the clients that we work with and work the best with is where they're underfunded. They don't have enough, capex or totex in their budget for the backlog of pipes that need addressing. So we've seen that no more than in the US market. So very excited to get into the US market. We're really looking for opportunities to work with North American clients to trial the product. We've developed it and changed the product so that it will fit US requirements. So very excited for that. And then on the product feature side, what we do, like you've mentioned, we catalog those defects using AI. We allow people to make up repair recommendations. What we're looking to do is say, okay, well, this is your current status of your pipes. Help people bring in the past status of their pipes as well, so that they can project forward and say what's going to happen.
The more intelligent it's going to be, isn't it?
Correct.
Well, Amanda, absolutely wonderful. I love the fact that you've taken your consulting and utility experience and devised something that is going to make a meaningful and quick impact on the sector. Brilliant. All the best. Thank you for your time.
Thanks, Scott. And you. Thanks, Piers.
As Amanda notes, they are active across the globe and they're growing fast. So if you're a utility and would like to know more, or if you're a potential partner who wants to work with them, feel free to email Amanda directly. And yes, her email, as shown here, is simply amanda.sequeira@vapar.co, not .com. For our next story, we stay in Australia, but we go a little bit south. We move from Sydney to Melbourne. And we're going there to hear from Jason Cotton, the Program Director at Intelligent Water Networks, also known as IWN. Now, you might recall that I last spoke to Jason in September 2023 when he shared tantalizing details about a project that they were about to undertake looking at turning biochar into batteries, or rather into supercapacitors, but the alliteration isn't quite as good there. Now, the Biochar to Batteries project has explored the feasibility of using biochar derived from biosolids as the active anode material for a sodium-ion battery and for supercapacitors. The project's been led by Barwon Water and has brought together a diverse consortium, including Deakin University, RMIT, the City of Greater Geelong, the water sector partners, which include Intelligent Water Networks and South East Water, and the Department of Energy, Environment and Climate Action, a whole host of the great and the good. The project underscores the water sector's potential role in the burgeoning energy storage crisis actually. It also promotes circular economy initiatives and creates new market opportunities for those utilities that might have lots of biosolids that they want to convert into biochar. So here is Jason sharing some more.
Jason, last time we spoke, you told me about a project you were doing in Australia on biochar and pyrolysis, and you teased us at the end. You said one of the things we're going to look at is, will the biochar be useful as a capacitor? And I was like, what did you mean? A capacitor? Biochar and batteries? What's this? And you promised that you'd come back and tell us about it when you got the results. So tell us about it. What was the project? Take me back a step. And what was the project?
Sure. Okay, Piers. So what we're doing is we're converting biosolids to biochar through a fluid bed pyrolysis unit, and it's a first of its kind unit that has been invented here by RMIT University. So we did some trials back in November where we got a variety of feedstocks. We got pure biosolids. We got biosolids that was blended with canola straw and pelletized, biosolids that was mixed with FOGO and pelletized, and we put those through the pyrolysis unit. And this was a brand new Mark II pyrolysis unit, about $1 million worth that we'd spent on this. And we then looked
at really nice beds, got no moving parts and things like that. So that's one of the
Yeah, absolutely correct. Yeah. So, and what we looked at was the characteristics of the biochar that resulted from those different blends at a number of different parameters that we were looking at, time and temperature and various other things. And also we did about 300 different analytes looking for PFAS and pharmaceuticals and all sorts of organic type products, contaminants as well. So this was quite an extensive trial run over a number of weeks here in Melbourne. So the results, it's great news. We were able to create biochar with different characteristics, different pore structures, etc. In terms of being able to use them for batteries, we are into the next phase of that project. So we actually won an R&D Excellence Awards here for that project back earlier this year in February, which was great. And so
the char can be used as a capacitor. What sort of things can it power? What are we talking about?
So biochar to batteries is actually, there's two sides to that project. The first one is to make anodes for sodium-ion batteries. We have been able to make a prototype of that, and that's actually what we won the Excellence Awards for. So they go into batteries that power things like mobility devices and wheelchairs and create a larger and longer lasting power source. The around the edges kind of approach, the blue sky, is the supercapacitor. And the supercapacitor is a device that goes into, say, a laptop computer or a tablet computer, and it gives a very short burst of powerful energy. So when you press the start button and it immediately starts up, that's the supercapacitor at work. And we have been able to make a prototype that does work and does have those characteristics. So the next stage is now, how do we turn that into a piece of electronics that we can put into a laptop?
Now, of course, it's technically possible. So this is great that it's Is it economically possible? Does it make sense? Because there's all sorts of things we can technically do. We can get to the moon. You know, we're not all going to go there because it's just. Does this really make sense from an economics and sustainability perspective?
Yeah, it certainly does. So there's a number of aspects to the economic analysis. One is this is a carbon sequestering exercise. So this is carbon that we are recovering from organics that exist. So we're not mining the carbon or creating that carbon from virgin sources.
Because the anodes need to be high quality carbon in the first place, wouldn't they?
That's correct. It would be a graphite or some other type of product, carbon product. And so that's the first benefit. The second one is that essentially this is coming from waste. So it's a circular economy exercise. So we are creating these carbon sources quite cheaply and able to use those. So we're looking, and here's another teaser. We're going to do a trial later this year and early next year that looks at creating a biochar that you can turn into powdered activated carbon for drinking water treatment. But anyway, I'll leave you with that.
And we're going to come back to that one. That's time around. Jason, it's always a delight speaking to you, and thank you for that little update, and thank you for the teaser for the next time. I'll talk to you in a few months' time, no doubt.
You're very welcome, Piers. Thanks for having me along. Cheers.
Bye-bye.
Thank you for that, Jason. Over the coming months, we'll be revisiting Melbourne to hear how Jason and the team at IWN are getting on with their Innovation Festival. Now, if you're an innovator, supplier, consultant, contractor, hell, even if you're a utility and you have an interest in developing opportunities in Australia, then this is going to be something you want to get involved in. Now, we all recognise that today water companies across the world face ever-tightening standards. They include for the treatment of micropollutants to almost non-detectable levels in drinking water, getting to very low levels of phosphorus discharge in wastewater, and the requirement to drastically reduce storm overflow spills. So what are the solutions that you can adopt? Well, NPure, a company based in the UK but who operate around the world, have a new innovative technology in the form of a proprietary silicon carbide membrane that might just be the solution. The technology they have provides unique advantages over potable water, wastewater and CSO applications. NPure claim that it will increase treatment capacities, reduce the costs and reduce the carbon footprint, arguably the three major drivers when selecting a process technology. Here is Mark Biddle, Engineering Manager of NPure, to explain a little bit more.
We're excited to introduce to you the cutting-edge technology behind our water treatment solutions, powered by Cembrane silicon carbide membranes. Through this short presentation, we'll explain who are Cembrane and what is a silicon carbide membrane, how does it work, why you should choose a silicon carbide membrane, what it can be used for, and finally, applications for treating dirty backwash water from RGFs and GAC. Cembrane are the market leaders in producing next-generation ceramic membranes using silicon carbide, after diamond the hardest material known to humankind. Silicon carbide ceramic membranes are submerged ultrafiltration flat plate membranes with a pore size of 0.1 microns. They act as a physical barrier that blocks solids and pathogens, allowing clean and disinfected water to pass through. This is a proven technology, having been supplied to more than 500 installations worldwide. This groundbreaking technology provides market-leading flux rates, longevity, robustness, and ease of operation, helping water companies increase their treatment capacities, reduce costs, and reduce their carbon footprint. The core of our technology lies in the silicon carbide membrane's unique properties. One of the key advantages of silicon carbide membranes compared to any other organic or aluminum ceramic membrane is their natural hydrophilicity, which attracts water while repelling organic foulings. This reduces membrane fouling, improving filtration efficiency, and reducing cleaning requirements. With high flux rates, these membranes reduce energy consumption and minimize the need for chemical cleaning. An array of flat sheet membranes are mounted in a filtration module, which are stacked in a tower formation, incorporating air scour distribution and permeate collection in the base section, with chemical cleaning sprinkler systems in the top section. Up to 15 membrane filtration modules can be arranged in a single stack configuration. This is not just a novel technology, it's a proven success. Our technology is trusted by a diverse range of industries, from drinking water and wastewater treatment through to industrial water treatment. These numbers are more than just statistics. They represent our commitment to delivering high-quality, reliable water treatment solutions across the globe. Our silicon carbide membranes are designed for high efficiency, durability, and chemical resistance, making them ideal for a wide range of applications within each industry sector. Whether dealing with surface water or seawater, or even industrial water, our technology delivers reliable and effective results. Our silicon carbide membranes are ideal for a wide range of applications within the drinking water sector. They can be used to replace traditional clarification and filtration stages. The filtration capacity ratios may be increased by up to 5 times. They can also be used in the field of wash water recovery, an application we believe has great potential. Conventional coagulation, flocculation, and clarification treatment, producing a supernatant with a turbidity of around 5 NTU, requires return to the inlet of the main treatment plant. The volume of this return represents between 5 and 10% of the plant abstraction volume. By replacing the traditional RGF dirty backwash water treatment with silicon carbide membranes, the permeate obtained is less than 0.1 NTU and can be directed to the main supply or to undergo further treatment downstream of the RGFs. The key advantages of taking this approach are over 95% recovery of filter backwash water with direct use downstream of filtration, an increase in the overall plant capacity of 5 to 10% through direct use of treated water rather than return to native works, a small footprint compared to conventional treatment, and no polymer dosing is required, reducing cost and mitigating the risk of adverse monomer concentrations in the treated water. In general, the key benefits brought by the adaptation of silicon carbide membranes are increased flow, giving up to 5 times more for a similar footprint, a low carbon footprint, they can be installed in existing tanks, negating the need to build new assets, consistent water quality, consistently produce water that exceeds regulatory standards independent of feed water quality variations, durability and reliability with minimal degradation or decline in permeability through prolonged use, vastly improving whole life costs, and operation efficiency. Low maintenance and remote monitoring capabilities minimize operational costs and provide optimum whole life costs. Cembrane and Empure are both part of the Skion Water family, who have a diverse portfolio of companies providing technologies for water and wastewater treatment to municipal and industrial sectors. Empure will deliver Cembrane silicon carbide membranes throughout the UK.
So, there you have it. If you're a utility looking to expand or improve your water treatment at low cost, low footprint and low carbon footprint, maybe silicon carbide membranes are for you. If you want to find out more, let me know, or get in touch with the Empure team directly, who will be pleased to provide more information. And finally, well, we finished today with a story that might seem obvious to many of us. The headline is "Fluoride doesn't lower your child's IQ." Now, I get it. It's a strange headline for me to highlight, and it begs the question, why am I doing it? Well, the reason I'm doing this is because a new report has recently been published which shows precisely the opposite. Indeed, this new report claims that fluoride could lower a child's IQ by as much as 2 to 5 percentage points. However, it's rubbish. It needs to be called out. It's bad science. So, what do you need to know? Well, firstly, the report is from the National Toxicological Programme, and it highlighted a study which linked high fluoride levels to low IQs in children. That's worrying. However, the NTP chose their own reviewers and the study was not peer-reviewed. More importantly, the fluoride levels that they tested, greater than 15 milligrams per litre, is higher than the concentration permitted even in toothpaste. What that means is that if a child ate a tube of toothpaste, they still wouldn't be exposed to the levels seen in the study. It's ridiculous. The fluoride levels they tested were more than double the amount used in the US community water fluoridation programs. The American Dental Association and the American Academy for Pediatrics both agree that water fluoridation is effective and safe and works to prevent tooth decay. So don't let bad science cloud your views. With that, we come to the end of this month's broadcast. Thanks again to our glorious sponsors and all the contributors. The next broadcast will be our special Christmas broadcast, and I'll be back sharing some stories about how water assets are used, or a better description is abused, in wars. It might not sound Christmassy, but it's an important topic and it needs highlighting. And we do have a message of hope at the end of the broadcast to share, so I hope you can join us. Until then, Keep asking questions, keep sharing, and keep safe.